Hi, my name is Peter Kowalczyk, and I'm presenting today my capstone project for the data science program. The project that I worked on is using sentiment analysis on 10K filings to predict oil prices. So as part of this project, basically what I was trying to do is to take natural language processing or NLP techniques, more specifically sentiment analysis, in trying to find a way to predict the price of a commodity. The actual commodity that I picked was oil. The idea is to be able to take 10K filings, which are required by all public companies in the US on an annual basis, and measure the sentiment in these filings, and from that sentiment relate that to the price of oil and see if there was a correlation or if it actually in reality I could predict the actual value. The idea from this project really came out of the literature review, and really here what I was trying to do is to answer the question, has this research been done before? So I started looking around, primarily around NLP and sentiment analysis. So I did find a fair bit of literature around using sentiment analysis in company filings, but I wanted to look a little bit deeper into that. So I looked into sentiment analysis on predicting stock price data. And a lot of the literature that I found was not on reports themselves, but on things like websites, Twitter feeds, social media in general. But I did find that in the SEC website, they do state as a guideline. It's not something that's required, but it's a guideline for all companies to provide some sort of broader market information. So here I started building the idea of using sentiment analysis to see if I can extract some of that broader market information from the 10K reports. I looked a little bit more into literature to see if anyone had already done this. What I did find was there were a few research projects out there using sentiment to calculate the perception of risk, and more specifically to even calculate the perception of risk in the financial sectors. So there is already some work being done in linking the report of a company with the actual broader market. What I didn't find, where the real gap is in taking a report and trying to predict the price of a commodity. And that could be any commodity. In my case, I took the price of oil, and that's really the gap that I found in previous research. So from that gap, I basically built three hypotheses, which are really the goal of this study, to try to either prove or invalidate these three hypotheses. The first one is it possible to build a linear regression with reasonable accuracy? In the methodology, I'll talk a little bit about what exactly is reasonable accuracy. But with reasonable accuracy, create a linear regression out of sentiment analysis from 10K report filings and calculate the price of a commodity. In this case, that commodity being oil. A second hypothesis would be, is there a regression that maybe doesn't predict the value of oil, but it can explain a lot of that? So it's still a regression analysis, but maybe making it a little bit more general, where we don't necessarily come up with a number for the price of oil, but we can explain a lot of the oil price fluctuation, why it goes up and down from sentiment that we calculate from the 10K reports. And then the last one is, can we prove that companies that actually work in the oil sector have their sentiment of their reports closely tied into the price of oil? So are they better either predictors or explainers of what the price of oil would be compared to a control group? And really the essence of this hypothesis is to counteract a little bit maybe the bias that we could find in sentiment for different reports. So here we're trying to make that difference between oil sector companies and the broader set of companies that don't necessarily participate directly in the oil industry. So for the methodology, what I did was basically divide the project in different phases. First one was sourcing the data, then preparing the data, calculating the sentiment analysis, modeling based out of the results from the sentiment analysis, and then analyzing those results with statistical methods. For sourcing the data, I took data from the Edgar website. I took over 1,200 different reports from different companies, and again, working towards those hypotheses, I basically took companies that are from the oil sector and non-oil sector. Companies from the oil sector, there's basically two big types of companies that work in the oil sector. Those are operators who work directly with the oil fields. They own the oil, and they make money out of selling the oil. And then the other set of companies are service companies. They work for the operators. They don't directly own the oil fields nor the oil produced, but they provide all of the technology for the operators to be able to extract that oil. So they're both very tightly coupled with the price of oil. And I basically took Edgar 10K reports for these two companies. And then I took a broader set of companies, companies that are not directly related with oil, companies in technology, software companies, hardware companies, the financial sector, some manufacturing, and some medicals. Once I had all of those reports, now I had to go into really preparing that data. One of the things that I'm going to show in the results is that we can't just simply take the reports and calculate sentiment on that. There has to be a little bit of preparation and validation of the data. So I'll show that in the results and in the different things that I did to clean up the data and prepare it for sentiment analysis. On the sentiment analysis section, I basically used a commercial sentiment analysis tool from Microsoft Cognitive Services. So this is a cloud-based solution. It's basically an API to which we can provide text, and it will calculate the sentiment being negative, positive, or neutral. And analyze all three, but I'll show in my results that one of the three is the one that was better suited for the type of analysis. And then in modeling, as I said before, as part of the hypothesis, calculating the regressions basically as part of my model. I'm using regression for two things. One, to explain the price of oil based out of the sentiment calculated, but also trying to build a model to actually predict. So in the analysis section, I basically measure the quality of the different models. These models were built with different sections of the reports. There was good findings there with different kinds of companies, and some produced better results than others. But the last one, result analysis, is basically determining if the hypotheses are true or not by looking at the quality of the models produced. So in the results, some of the findings were, as I said before, I found that you can't really take reports and calculate sentiment straight out of them. And these are two examples of the reasons why. So here I'm showing individual reports of service companies, and the A part, and the B shows companies from the control of the non-oil sector companies. So what we can see here is right in the middle, we see, well, first of all both graphs show results from the sentiment analysis tool. So that step in the methodology. and it shows positive, negative, and neutral content for each one of the reports done. What we can see in the A piece is right in the middle, how one company, even though all of its peers show negative sentiment, that company is always showing positive. And this is using the entire report. And we see similar things in the control, right? In the control, we see in two different companies reporting for the same period, and one is completely neutral, the other one is completely negative. So one of the things I did was, instead of taking the entire report, and I found some of this in the literature, instead of taking the entire report, I took different sections of the report, mainly sections or items 1 and item 7, that they seem to contain the most richest information about the company and hopefully the broader market. So that was one finding. Once I did that and I extracted just those two items or those two sections, what I'm showing here on the left-hand side is a plot of all of the sentiment. It's a histogram plot of the entire data set. So we can see that sentiment is building. There's quite a bit of overlap. The distributions are not quite normal, but we can see a center, somewhat of a mean for each one of the three. But there's a fair bit of overlap. Now, this is for the entire data set for all of the years from 2000 to 2022, basically, and for all of the companies. So one thing that I did was I worked on using a yearly sample period. So for each year, I bootstrapped the information that I had to calculate a distribution, a normal distribution for the three types of sentiment, and then I made sure that there wasn't any overlap. The idea would be is that if I found a lot of overlap, I would discard that year or filter out some of the data as part of my data preparation. But what I found was that for the most part, the entire data set was showing, like I'm showing here on the right-hand side for 2015, where the data is very discrete. So even though for the entire data set, it seems like there's a lot of overlap, for individual years after bootstrapping, we can find a very fine mean for each one of the three sentiments. And I did that for every single year of the analysis and discarded where I did see overlap. So once we clean out the data like that, I could plot the entire data set, which is what I'm showing here on the right-hand side. So I've got the three different sentiments plotted up against the price of oil. And I'm using two indices for the price of oil, West Texas Intermediate and Brent. So those are basically a US index and an international index, which basically follow each other. So from this point on, I was using WTI, or West Texas Intermediate, for all of my modeling and my calculations. What we could probably try to do some sort of correlation between the price of oil and the different sentiments. But instead of doing that, I really tried to build a model. So that's what I'm showing on the right-hand side. So I'm showing there, if we look at that graph, there's two sets of points, and that's positive and negative sentiment from all of the reports plotted against the WTI price of oil. And what we can see is on the left-hand side of that plot, for the positive points, we can see that the price of oil goes up as the sentiment goes up. As the more and more positive the sentiment in the reports is, the higher the price of oil seems to be, just from that distribution of points. On the right-hand side of that graph, we can see basically the opposite for negative sentiment. When we have more and more negative sentiment, the price of oil seems to be dropping, again, just by eyeballing a linear regression going through those points. So this gave me a really good warm and fuzzy that a model could be produced. So from this point on, I started producing models of sentiment against WTI oil prices. So one of the things I had to do, because I have two hypotheses, one for predicting the price of oil and another one for explaining. I'm basically looking at regression models from two different quality KPIs. One being the mean square error, and I'll use that to calculate the quality of a model that can predict the price of oil. And my hypothesis basically says a reasonable quality, right? For that reasonable quality, I did a little bit of research, and what I found was that there were several models out there, not sentiment analysis related, but oil prediction models that I showed in my references that are able to calculate that predict the price of oil within $2. So I'm using a quality metric of MSC of $2. And as you can see on the left-hand side on that graph, the distribution here is way above $2, is several hundreds of dollars if we take the entire span of that distribution. And I did this for sentiment of the control of operators of service companies, of non-oil sector companies for different years, and that I sliced it back and forth, and really I couldn't find a model that would fit within that $2 MSC target. So that's basically the conclusion for hypothesis one. Now, to be able to explain some of the price of the oil from a regression model, now what I'm looking at is at R square, and that's what I'm showing on the right hand side. For that, I did find models that, although still show fairly high R square distributions, and all of this data that I'm showing here is bootstrapped. So it's, even though the distribution is pretty wide, the R square means themselves and the shape of the distribution seems to be pointing towards the possibility of having a model that can actually explain that price of oil. So I did find some models like the top one on the right hand side, which show very poor distributions, but some others like the one at the bottom are starting to show more normal distributions. So hypothesis two is still up in the air. It seems like it's possible to build a model to explain, not to predict the price of oil. So I did a fair, for hypothesis three, I did a fair bit more of slices and dicing, and what I'm showing here is some of those results. So there, what we're trying to say is it true? Can we confirm that companies that work in oil and gas directly have their sentiment of their reports closer tied into the price of oil, which would be a reasonable assumption. They're closer to oil, the price of oil and the oil market, and they're affected a lot more. So they should reflect some of that price. But my findings were that that's not really the case. So I'm showing here different models that I computed using just operator companies and service companies, and then using also the service companies by themselves. I generated some with just operator companies, and they really don't show better results than the entire population. So hypothesis three, again, it's not confirmed. In fact, I basically found that it's better to look at a broader set of companies that try to use companies that are closer related with oil operations. So it's part of my conclusions. I basically have conclusions for all three hypotheses. I did not find a model that would be used to predict the price of oil. So hypothesis one is not confirmed. Hypothesis two, I did produce models, even though of low quality, but models that could be used to explain the price of oil. So that's more looking at the R square, some of these models. And then the third one is I did not prove that oil companies, either operators or service companies, produce better results than companies from the broader sector. So going forward, some of the analysis that should follow this study would be um, maybe to better understand why is it that oil companies don't are not closer related to the sentiment. It might be because the data is completely skewed, which was one of the risks that I highlighted when I started this project, and the reason why I'm using a control group. Um, but also maybe looking into some other types of model, maybe not just a regression model, but other types of models that could explain better the price of oil. And also looking at a little bit deeper into the effects of maybe the language and the tone of a company in specific. So instead of eliminating that from the data set, maybe doing some sort of normalization of the sentiment based on either stock price or something like that to be able to include that data in the study. And that's all for my capstone project. Thank you.